All right, so perform the indicated operations. All right, number one. All right, let's suppose we had the square root of a negative 49, square root of a negative 49, minus the square root of a negative 25. Square root of a negative 49 minus the square root of a negative 45. Now, you all know what the square root of 49 is. What's the square root of 49? You need your calculator for that. You better have to use your calculator for that. The square root of 49? 7. What's the square root of a negative 49? 7i. 7i, not negative 7, because what's negative 7 times negative 7? 49. That's not negative 49. So remember, when dealing with square root of a negative 49, for some of you did not see that this was a 7i, you may want to go off to the side and kind of do what I'm doing here. So you need to know that the square root of negative 49 means the same thing as the square root of a negative 1 times the square root of 49. Okay? So I can rewrite that negative 49 as a product of two square roots, a negative 1 times 49. But what is the square root of a negative 1? That was one of your definitions. What's the square root of a negative 1? I. What's the square root of 49? So this is I times 7, but don't write it as I times 7. Mathematically, we prefer to write it with the coefficient listed first. So how are you going to rewrite this? 7i. So this part right here is just 7i. Minus? What is the square root of a negative 25? 5i. Again, if you did not know that that was 5i, and remember, it's not negative 25. Don't say that the square root of a negative 25 is negative 5, because negative 5 times negative 5 is not negative 25. Negative 5 times negative 5 is a positive 25. So if you need to do the same thing, then you do the same thing. So if you're going to do this, then how would you rewrite the square root of a negative 25? You're going to say what? Times the square root of 25. What's the square root of negative 1? I. Square root of 25. So I times 5 is the same thing as what? 5i. So this is 7i minus what? Can I combine like terms? Yep. What's the answer? 2i. Number 2. You have 3 times the square root of a negative 144 plus 2 times the square root of a negative 81. So 3 times the square root of a negative 144 plus 2 times the square root of a negative 81. All right, let's deal with the square root of a negative 144. What is that? 12i. So this is 3 times 12i. Okay? Plus 2. What's the square root of a negative 81? 9i. So 2 times 9i. What's 3 times 12i? 36i. Plus, what's 2 times 9i? And using your calculator if you need to, what's 36i plus 18i? 54i? Okay, that's number 2. All right, number 3. All right, number 3, we're going to use either tonight or tomorrow night, that idea. So it looks like this, though. It's negative 8 plus the square root of a negative 50 divided by 10. Now, you had this last semester when you solved quadratic equations using the quadratic formula. You notice that this looks like using the quadratic formula. All right, now the problem with number 3 versus the other two is that the other two, negating the negative sign there, 49, 25, 144, and 81 are perfect squares. But is 50 a perfect square? No. So remember what we did last semester was we had to simplify that square root of 50. So we had to think about, well, what perfect square goes into 50? 7 is not a perfect square. 25. 7 times what whole numbers? Who said 7, by the way?
I did.
So 7 times what whole number is 50?
I was thinking
Okay. All right. So the square root of 50 is the square root of 25 times 2, right? Okay, remember how we wrote this? So 50 is not a perfect square, so what you have to think about, well, what perfect square goes into 50? So you got to remember what your perfect squares are. Your perfect squares are 1. What's the next one? 4. What's the next one after 4? 5 is not a perfect square. 9. What's the next one after 9? 16. 25. 36. 49. 64, and so on. So remember, these are perfect squares, and we're going to use that idea this week as well, the idea of perfect squares. It's a perfect square because I can write each of these as a whole number square. 1 squared is what? I'm sorry, 1 is what? 1 squared. 4 is what? 2 squared. 9 is what? 3 squared. 16 is what? 4 squared. So that's how you get your perfect squares. You keep going that pattern. 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, and so on. So that's why those are perfect squares, because you can write each of those numbers as some whole number raised to the second power. So when you're looking at 50, I'm not using negative 50 right now, I'm looking at 50. When you're looking at 50, is 50 one of these numbers right here? No. But what you learned last semester was, well, I need to simplify the square root of 50 still. And I need to simplify the square root of 50 using the largest perfect square that goes into 50. Which of these perfect squares, the largest one, goes into 50? 25. So you're going to say square root of 50 is square root of 25 times 2. And then you wrote, see how I wrote this right here to get this? The same thing here. So you're going to say this is square root of 25 times the square root of 2. And what's the square root of 25?
5.
So you get 5 square root of 2. So that's what the square root of 50 is. Square root of 50 is 5 square root of 2. Okay? But I wasn't interested in the square root of 50. I was interested in what?
Negative.
Square root of negative 50. So let's think about that then. All right, well, if the square root of 50 is this, then let's think about the square root of negative 50. That's the same thing as saying the square root of a negative 1 times the square root of 50, right? Y'all agree?
Right.
What's the square root of negative 1? I. What's the square root of 50 simplified? 5 square root of 2. Okay, so that's where I'm at. All right, so I know that number 3 is going to have an I in it. It's going to have that imaginary number in it. All right, now remember a while ago when I said right here where we had that I times 7? Don't write as I times 7, write as what? 7i. Okay, now notice the way that this one looks. You have I times 5 times the square root of 2, right? So in this one here, you have a square root still listed. We prefer to rewrite this where I is between the 5 and the square root of 2. So in other words, you're going to write this as 5i square root of 2. Now, it does not matter, guys. If you put the I on the outside, just like we did here, see like this, you just got to be careful. You got to make sure that the I does not look like it's under the square root, because it's not supposed to be under the square root. Where's it supposed to be? On the outside. Okay, so make it look like this. If I think that it looks like it's underneath, you're not getting full credit, even though you're going to tell me, well, that's what you meant. All right. Okay, so there are several ways you can write this, but don't put it out in front. Either put it between the 5 and the 2 or put it on the outside of the square root. All right, now what if you had this? What if you had simplify? Now we're still not done with number 3, but what if you had simplify the square root of, let's say, negative 45. All right, well, is 45 a perfect square? No. Then you got to ask yourself, well, can I simplify the square root of 45? I know it's negative here, but let's think about the 45 for right now. Can I simplify the square root of 45? Let's think about the square root of 45. Is there a perfect square? And we're using perfect squares because this is square root. So we're using perfect squares. Is there a perfect square, the largest one, that will go into 45? 9. 9 is the largest perfect square that goes into 45. So I can write this as the square root of 9 times what? 5. So you got to make sure that one of these is a perfect square. So don't say 13 times 15. I'm sorry, 3 times 15, excuse me. 3 times 15, because 3 times 15, none of those are perfect squares. You want to make sure one of these is a what? Perfect square. And always use the largest. Makes things easy on yourself. So remember last semester we did some examples where we didn't use the largest and you had quite a few steps. Now, once you find the largest perfect square, you're going to rewrite it. You're going to say the square root of 9 times the square root of what? 5. Now, what's the square root of 9?
3.
So you get 3 square root of 5. Okay? But I wasn't interested in the square root of 45. I was interested in what? Square root of negative 45. All right, well, let's think about what we did earlier, beginning of class. Well, that's the same thing as saying the square root of a negative 1 times what? Square root of 45. What's the square root of negative 1? I. What's the square root of 45? 3 square root of 5. So how are you going to write this? There are two ways you can write it. You can say 3i square root of 5. You can say 3 square root of 5 times what? I. Okay? All right, so that was a quick review of simplifying radicals from last semester. Now let's go back to number 3. All right, so I needed to simplify the square root of negative 50, which I did. What's the square root of negative 50 simplified? 5i square root of 2. So I'm going to say negative 8 plus 5i square root of 2 all over what? 10. Okay? All right. Now, the directions are going to say write this in standard form. Now, many times, though, the directions are not going to say anything like that. So you can leave your answer like this. Once you simplify the radical and there's nothing else you can do, then leave it as this one fraction. But in this case, if you look at that worksheet, it does say write in standard form. So just like you did yesterday, just write this as 2 fractions. So you can write this as what? Negative 8/10 plus what? 5i square root of 2 over 10. Now that's where I'm at, okay? But now you got to reduce. Look at that first fraction, negative 8/10. What's that reduced? Negative 4/5. All right, now you got to be careful with this one here. Some of you are going to say, well, 2 goes into 2 one time, 2 goes into 10 5 times. You're going to try and reduce the 2 and the 10. But you got to be careful. That is not 2. If you take your calculator out and you put the square root of 2, that's not a 2. It's the square root of 2 in your calculator. It's like 1 point something, no, and it doesn't repeat or end. So it's quite a, but it's not 2, right? All right. So don't do 2 into 2 is 1, 2 into 10 is 5. Okay? But can I simplify the 5 and 10? Yes, that you can do. So that's 1 and that's what? 2. So you're going to say I square root of 2 over what? 2. Okay? All right, so as you're doing that, the last 4 problems of that worksheet, just make sure you look at this. And I think there's some, for the video and that on Canvas is on this as well. Let's look at number 4. All right, number 4. You have negative 18 minus the square root of a negative 27 divided by 21. All right. So it says perform the indicated operations, simplify if you can, combine like terms if you can. So given those directions, what are you going to focus on right now? Square root of negative 27 first. That's what you need to focus on at this point. So we're trying to figure out what the square root of a negative 27 is. What I would do at this point is rewrite square root of negative 27 as a square root of a negative 1 times the square root of 27. Now you know you're going to have an I there, right? How do you know you're going to have an I there? Because you're taking the square root of what kind of number? Negative. Taking the square root of a negative number, so you're going to have an I. All right, so I know the square root of a negative 1 is what? I just got to figure out what the square root of 27 is simplified, if I can simplify it. Is there a perfect square besides 1, and always use the largest, that goes into 27? 9. So that's 9 times 3. So this becomes a square root of 9 times 3. So that's I, square root of 9, square root of 3. And what's the square root of 9?
3.
So I'm going to get 3I square root of 3. Okay? So that goes here. That goes here. So that's negative 18 minus 3I square root of 3 all over what? 21. All right? Now, the directions, listen carefully to this, the directions for this part here does say write in standard form. Okay? So since it said write in standard form, you're going to write this as 2 fractions. So you're going to say negative 18 over 21 minus 3I over square root of 3 over 21. Okay? I can simplify, reduce the first fraction. They're both divisible by 3. So that's negative 6/7 minus, no, I can reduce the 3 and the 21. Now which 3 am I going to use? First one. So look, this is what you're dealing with. So you're saying 3 and 3 is 1, 3 and 21 is what?
7.
So what's your answer?
I square root of 3 over 7.
Yeah. Okay, so that should take care of that worksheet now. All right, so that worksheet is going to be due Tuesday. 1.4 part 1 will be due Tuesday. Okay? All right, now